Okay, so tonight, virtual manipulatives to deepen mathematical understanding with two wonderful presenters, Mike Flynn and Zach Champagne, both from Flynn Education. They are both they're both authors, and they have teamed up on Flynn Education to deliver professional learning experience to help elevate teaching, and they are both dedicated to promoting positive changes in mathematics education. So, with that, I am going to stop sharing and get out of their way so that we can begin. So, thank you guys. It's all yours.
All right, perfect. Thank you so much. And Marco, you able to put a spotlight on me so as I share my slides in the perfect, got it all set. All right, friends. So we're super excited to have you all here today. Zach and I have been in education for quite some time. We were both elementary school teachers. I moved into higher education. He moved into research, and that work has brought us to do a lot of work with middle school and high school teachers as well. So now we basically teach TK, pre-K through 12th grade and support teachers all around the world. And we're really excited to do some work with you because a big part of our work has to do with making math visible, making it tactile, making it using representations to deepen understanding and make really meaningful math connections. So I'm going to begin by actually sharing a story to frame our work. And this is a story that I used to read to my second graders when I used to teach. And it's about five blind men that were walking along out in the wilderness, and they happened upon a creature they had never encountered before. And they were confused. They were perplexed. They'd never seen anything like this before. They've never encountered anything like this before. And so they all decided to touch one part of this creature to get a sense of what it was. And they each made a declarative statement that they knew what this animal was like. And the first one said, "It's like a giant leaf. It's just like thin and flat and big." And the other one said, "No, you're completely wrong. It's like a tree trunk. It's like sturdy and round and solid." And the other one said, "You don't know what you're talking about. It's like a frayed rope. It's like a rope, but then it's got sort of tassels off at the end of it." And the other one said, "What are you talking about? It's like a big wall. It's just like rough and hard and broad." And the last one said, "No, it's not. It's like a giant boa constrictor or anaconda. So they all were arguing and disagreeing. And the problem was is that they all had one part of an understanding of what this creature was because they were only seeing it from one side or interacting with it from one part of it. But when they put their pieces together, you can imagine that they understood what the full uh, all the features of that creature put together, realized it was an elephant. And what was happening was that they had each a small part of the picture, but it wasn't until they put it all together that they got the full understanding of what an elephant was. And this is not unlike what we see with math. In math, there's lots of different ways that we can represent a math idea. And this comes from lots of different research. I'm going to cite Van de Waal for this one here, but like we could represent a mathematical idea using a physical model, using manipulatives. We could represent that idea verbally by describing it in writing or in just in words to a friend or a colleague. We could sketch a picture or use virtual manipulatives to show that idea or represent it through equations or even put a story context around it. All of these ways are ways that we see the same mathematical idea slightly differently. And where the power of learning comes in is when we connect those ideas. So that if Zach was working on some division and he decided to build out his representation or his strategy using a base 10 model, and Mark was doing this a numerical strategy, and I was using a place value pictures, and you get the idea that we could start to have these different ways we approach it. But then if I said, where do I see Mark's numerical strategy with Zach's model? And we start to make connections between the way Mark was doing it and the way Zach saw it. That's where we start to really develop that solid conceptual understanding. That's what we're going for here. So when we talk about using virtual math manipulatives to deepen understanding, where it's all about connection. It's not just about using the manipulatives. There's so many great manipulatives that Brainy Camp has to offer, and it's great to get kids into it. But the role of you as a teacher is building these connections, and we do that by asking really good questions. And one of our favorite questions is, where do we see this in this. So where do I see division in Zach's base 10 model? Where do I see division in Mark's numerical strategy? Where do I see it on the number line? Where do I see these things in this thing? That's kind of how we build these kind of connecting questions. The last thing I just want to share with you before I turn it over to Zach and have us do a little bit of math is a big part of what we're going to do tonight is we're going to have a lot of things that have direct connections to classrooms. So everything we share is something you could use with students. But our focus for this evening is actually on your own knowledge. It's on building your own knowledge. And so I don't know if you're familiar or not with Deborah Ball's research on math knowledge for teaching, but Deborah Ball and her team, they've done a lot of great research around this. In fact, my dissertation cited a lot of their work, but it's really powerful stuff because what their team identified was the knowledge that's necessary to teach math really well. And we often think for the knowledge we need as a teacher is we just need to know the content and we need to know how kids learn it. So content knowledge and pedagogical knowledge, but it's much deeper than that. So what Deborah's team identified is the math knowledge on the content side that's needed to teach really well involves common content knowledge, which is you know how to do the fifth grade math or you know how to do sixth grade math or first grade math. And it's the knowledge that we expect like most people would have. And it's good. You need that. But the thing that sometimes can be lacking and that we always are going to be working toward is building our specialized content knowledge. And what this is, it's the knowledge of the math that you're teaching, but understanding it from many different perspectives. Okay. Going right back to the elephant story, right? It's not about just having one way to think about it. It's knowing all the different ways. And so tonight we're going to be pushing into that specialized content knowledge for you quite a bit. And then the other one is knowledge at the mathematical horizon. And what the knowledge of mathematical horizon refers to is it's what's come before the knowledge that students have experienced before they come to you, and it's the knowledge that they experience after they leave you. And so when you understand the knowledge on the horizon from the grade that you teach, it really strengthens your knowledge of the whole math story that kids get. And it helps you with differentiation because you understand you have lots of kids that may not be doing the same kind of work that you'd expect most students to do at that grade level. It might be like just emerging in some ideas, or you have some kids who need some extensions and challenges. Knowledge at the horizon really helps you to differentiate really well. And so tonight we're going to be doing some tasks where if you teach upper elementary, we're going to do some things that fit in the primary grades. And if you teach in the primary grades, we're going to be doing things that are in upper elementary or middle school. And it's important to recognize as teachers, learning math that's not the math you teach is also really powerful for your own learning. So for tonight, we're just going to focus on the content side of things. We'll get into some of the pedagogical side of things, but we're going to really kind of push into spaces and challenge you. And while doing that, we're going to give you some good ideas for things that you could do with your students. So I'm going to just share one example as just a way that this might not be something that you teach, but you're going to learn something really powerful with this. So I'm going to share something as a second grade teacher. I would encounter this a lot, and I had a lot of colleagues, and when I work in schools, teachers will always say like one of the things that's really frustrating for them is having kids work with an analog clock. So one of the first things that, oops, let me jump to that here, is a thing that I found really cool that I could do in Brainy Camp was to do what's known as the broken clock. So one of the things that's really hard for students when they're telling time is recognizing like you've got so many hands happening, so it gets really confusing for them around what thing they're supposed to focus on. And so what I did when I used to teach, much to the chagrin of my principal, is I got our classroom clocks and I just got some pliers and I ripped all the minute hands off the clocks. You don't have to do that anymore, thankfully. But the whole idea with the broken clock is the clock only has an hour hand, which means you can't tell precise time, but you can tell approximate time. And so if you want to see what this looks like, I just set up a quick one here if you wanted to kind of play with it. But what's great with the clocks feature in Brainy Camp is that you can actually just get rid of the minute hand and you don't get in trouble for destroying school property. And you can go ahead and use that share code there. You can just enter that in when you're logged into Brainy Camp, and it'll take you to this template that I've created. But what you do with the broken clock is you show it to the students and you just ask them about what time is it. So looking at that first clock on the left, about what time is it? Go throw that in the chat. Oops. So you got to look at the range. So some people are saying it's about three, some are saying four, some are saying 330. And this is what's great with this. Just this task alone, you start to get these different answers, and you say, well, let's talk about it. Give me your reason why. So why is it about three? Why is it about four? And you realize when you start to get into some of the justification, some people might say, well, it's almost halfway, but it's a little more than halfway, right? Ah, yeah, you see that there is method to my madness, Heather. You get it. There is something I'm doing here. The whole idea is to promote conversation. But what's cool with this is the conversation starts to get around the nature of the hour hand. Is it just past the hour? In which case it's going to be just a few minutes past the hour. If it's really close to the next hour, is it right in between? And all of a sudden they start to realize that you can pretty much, the hour hand's the most important hand. And then you would actually, then you could say, so then what would happen though if we needed to be somewhere precisely at 9:17, and that comes up as a problem, and then that's when you introduce the minute hand. And so that's just a quick little tip for you. I wanted to just show a nice easy like launch ramp here for virtual manipulatives. But once I discovered this, I found a great way to do the broken clock without getting in trouble. So with that, I'm going to turn over to Zach to actually get into some math where you're going to play for a little bit, but feel free to share this task with any of your colleagues, especially if they have to teach anything with the analog clock.
Thanks, Mike. You'll quickly learn that Mike and I love just about any math task with ambiguity in it, and that's a lovely one with some great ambiguity, right? Like you have to make a case for where it is. I think someone also commented in the chat box, it may have been Heather again, that with that one, Mike, we know it's not before three, and what a lovely realization that is, right? Like we know it has to be after three, somewhere between 3 and 4 o'clock. But man, super fun task to play with without getting in trouble from your principal for prying a minute hand off the clock. So what we're going to do now is we're going to play with a little bit of math. One of the things that Mike and I tried to do with the math that we brought to you all today was to try and get away from some of the more typical Braining Camp apps you might use. Like we have so much that we could have done with base 10 blocks that we were really excited about, but we wanted to kind of get into some of these other apps in here and play with those. And the first one that we're going to be working with today are those geo boards. Speaking of not getting in trouble, when you don't have the opportunity to flick a rubber band across the room because the geoboard rubber band is digital. That's a lovely win for your kids and for you as well. We love geoboards over here, and like we use them a lot. But man, they are one of the harder manipulatives to keep in check in your classroom. Let's just be honest. We know how those rubber bands can fly. We also know that at times they can be kind of sharp, a little dangerous at times if you fall on one or you put your elbow on one when you're leaning over. So anyway, we love the geoboards, and if you want to go ahead and pop into the geoboard app, you can. But I want to start by just getting us to talk about a little activity that we call quirky cakes, which is it comes from a course that Mike and I have over at Flint Education, and you guys are going to dive into kind of like the middle of where this is. You've already done some work at this point around cutting cakes into two pieces, and these were cakes that were not shaped like a normal cake. So they were kind of irregular shapes, and you had to make some justifications about where you'd make a cut to cut it into two equal pieces, or to decide if this cut was into two equal pieces. And what we're going to do now is we're going to start with just some square cakes. So we're going to start with like this here. And this is just a screenshot from Braining Camp where I put a rubber band around a 4x4 square here. And you can kind of see those pegs there to kind of know where they are. And what we're going to do right now is I'm going to ask you just to take a moment and just think about some ways that you could cut this cake in half. And you can just drop it in the chat box using your words, how you might cut this cake in half.
And Zach,
Grace
I can
says,
read the chat for you if you want. You
perfect.
can, if
Yeah.
you're going to do any annotation or anything. Yeah. So
Yeah.
I see diagonal, left to right,
Perfect. There's your
vertically.
diagonal, left to right.
Yeah.
We get up and we got vertical. Yeah. Yeah, these are your typical ways we'd cut this thing in half, right? And these are the things that, most young people would talk about when we're cutting things in half. But what we want to do is push on that a little bit and think about what are some other ways we could cut this in half. And so what we're going to look at now is I'm going to show you another image, and I'm going to ask you to think about if it's actually cut in half. Now, this is a quirky cut. It's not going to be one of these three here, but you're going to be thinking, is this cut in half? And then what we'd like you to do is to answer that in the chat box, but also give us your justification. How do you know it's cut in half? And this is the one we want you to take a look at, and I'll make it full screen here for you. And I want you to think about, is that cut in half? And Mike, I'm going to ask you to talk through it in just a second, but I want to give them a few seconds to put some things in the chat box before we steal some math thinking from them. Starting to get a few responses in there. If you're still thinking, take your eyes off the chat box. Don't let them steal your thinking. Yeah, we're getting some good justification in there, Mike. I like this. Give everybody another 15 seconds or so before we start talking through this. Ooh, now I am starting to see some things about squares and pegs. I love it. Oh, now we've got some triangle language in there. Mike, you want to talk us through this one? What do you notice about this one? How do you know? Is it cut in half and how'd you think about it?
That's great. So actually, I agree with a lot of things. I think people are recognizing that the whole cake is 16 square units. So if I'm going to go ahead and just annotate for a second. I don't know if people can. Mark, if you can add a spotlight, if you click on mine, it'll say add spotlight. Perfect.
Boom.
So like Zach, what I'm kind of doing, I'm going to go full screen here. So it's just right next to you.
Yep.
Oh, let's go. That's better. So if I kind of think about like this is like a square unit, right? So the first thing
Yeah.
I'm kind
Yep.
of doing, it seems like a lot of people were kind of looking at that. So we've got like 1, 2, 3, 4. And then this here, it's a half of one, right? So I'm just going to do one half. And then here's another half. This one's actually a whole one. So that'll be 1, 2, 3, 4, 5. And this one also is part of this one on this side, right? So there's
Yep.
6. I have a half here and a half here. So these two halves, this half and this half make another whole. That would be 7, and this half make another whole. So that would be 8. So based on the that one side there being 8 square units, we can infer that the other side is also 8 square units.
I love it. I love it. So you're not even going to bother counting the other side, Mike. You feel like because there's 8 over there, there's got to be 8 on the other side. Is that
Final
correct?
answer, Zach. I'm locking it, and I trust the math.
Trust the math. Okay. All right. I love it. I think we're all feeling good here. We've got this first quirky cake down. We're going to do one more together before we send us off to do a little bit of play and exploration. But I want you to take a look at this one now. And Mike, if you'll take your picture off just so we don't confuse them which one they're looking at, or you can even just take your annotations off maybe. But the next one, yeah, there we go. Next one we're going to look at is this. Take a look at this one now. Give yourself a little bit of time here and decide, is this cut in half?
This one's gnarly, Zach.
I know. It's too fun though, right? There's something about that, and if you're thinking through this one, you can mute me for a second. But there's something about that first diagonal, Mike, from the middle top down that goes through 3 squares that really throws my brain. That's really hard to decide like how much of each one of those is
Yeah,
there, right? Yeah, Julie's feeling the pain a little bit too.
it is harder to see. Yeah.
So maybe to make this a little easier to see, what I've done is we've went ahead and built these first two for you. Yeah, Carolyn wants some dotted lines. I like that. We've built these for you in Braining Camp, and I think Mark just put a share code in there, but I'm gonna show you real quick. Just when you get into this, when you use the share code in just a second, you're going to see what I see here, which is I've already built sort of 8 of these boards for you, and the first 2 are there. But I'm just going to click play on this video so you can kind of see some of your opportunities to build these. You can use the rubber band feature by just dragging it over and then dragging those there. So we're going to ask you to create some of your own quirky cakes, and you can use that. You can also just grab that pin, and you can use that. If you want, you can make the pin a little bigger. That's a little easier to see if you use the little squigglies on the bottom there. And then finally, over on the left, you can use the shape tool. If you want to get a line that way, you can get a line segment there. You can use the shape tool to input those in. So those are three ways that you can interact in creating your own, but there's also three different ways that you can kind of sketch on the screen and decide is it equal or not equal by using the pen tool or using some of your own rubber bands or again these sort of line segments. You can see I had a little harder time with the line segments than I did with the rubber bands or the pen, but we want to make sure you have options there to engage in this work. Now, what you need to know is if you haven't used a share code before, when you go to the main Braining Camp page in the top right-hand corner, you'll see a share code. Jeff just put it in the chat box. You can copy and paste that right into the share code there, and it should get you to your own Quirky Cake page. Myra, I'll say it one more time. And actually, what I'll do here is I will share my screen so that you can see the Braining Camp app here. So what you're going to do is when you log into Braining Camp, up here in the top right-hand corner, you'll see share code. You're going to copy that share code, put it right in there, and it is FT5766PG. And when you hit go, you're going to be brought to the page with that there. Now, just as if you're new to share codes, what you do need to know is that you now have your own copy of this. You're not messing up anyone else's work. You can do whatever you want with it here. This is now yours. But you don't have to, again, you don't have to worry about Mike popping in and moving one of your rubber bands. This is now your space to play. So we encourage you to do that for just a minute. And we'll just check on. Oh, Mark's giving you some pro tips over there on using those rubber bands. At times, sometimes you'll pull a rubber band where you don't want it to go. The other thing you might want to know is that in the bottom left-hand corner, you do have an undo button. So if you ever get too quirky with the rubber band, it's out of there. You can hit the undo button. It'll take you back a few steps, get you where you were. And now, as you're playing with that one we were just thinking about back here on this one, as you're playing with that, if you come up with a solution as to if it is in fact equal, go ahead and drop that thinking in the chat box. And Mike, in just about a minute, I'm going to ask you to talk through this one and see what you think here. Give you a chance to prepare yourself and your reasoning.
Bet.
And Jeff, will you go ahead and spotlight Mike again? I'm imagining he's going to have some drawing he needs to do here. There we go.
Oops. You ready for me to do some chatting?
Almost. I'm just going to respond. Mike, we're going to give them a link to get the slides later on. Is that correct?
Yeah. And actually, I dropped it in a little earlier. I'll put it back in now if people are wanting the slides. Okay. So
Aaron,
it's right
we see
there.
your message there. Perfect. Yeah, Mike, why don't you start talking us through this? We got a couple of responses coming up in there. We've got one from Adina and Grace. If you are still playing and you don't want your thinking stolen just yet, you can mute Mike for a minute here. We just don't want to have a lot of dead air time here. It makes it kind of fun if we talk through it. So, Mike, talk us through here. Do we think we have a cut that gets two equal halves?
I do.
Okay.
My first way when I thought about it was I was trying to it got really complicated because I was trying to match pieces. So I was like, all right, so if you look at this little bit of a piece here, excuse my bad drawing with the Apple Pencil. And then I was like, well, does this little wedge here fit that same spot? And it was like, oh, that's a lot to hold on to. And then it dawned on me is if you kind of look at this rectangle right here, if I just kind of make this outline right here. So that's a 1x3 rectangle, right? So it's 3 square units. And you could see that this red line here cuts that in half. And so I know if I have something that's 3 square units and I cut it in half, I don't need to know if these are all if these pieces fit together in any way. I just know that this is actually going to be 1.5. This whole side here is 1.5 square units based on this rectangle. So cutting that. So then I can go through my same process of let's look at all the whole ones. So I have 1, 2, 3, 4, 5 whole ones. And then I've got the 1.5, which is this section up here in blue. And then here, this is a very clear half. And then I can actually use that same rectangle. I'm going to use a different color here, green. So this here is like a 1x2, so 2 square units. So then if it's cut in half, then I know that each of these halves is equal to 1. So this part here is equal to 1. and then this is a half. I'll keep it consistent with decimals this time. And so you can go 1, 2, 3, 4, 5. This would be 6, and then um, 7 is the whole part here, and I can put those two halves together to get 8. So it's a very messy way, but it is 8 square units on that half, which means the other half is also 8 square units. Final answer.
Look at that. Mike Flynn, everybody. You got a couple comments that was a little more what was the word? Not efficient, but a little simpler than other folks went about this. So nice work on putting that eloquent response together. I always remind people when we talk about efficiency, I like to remind us that efficiency is in the eye of the beholder. And for what's efficient for Mike might not be efficient for you, but I do like this rationale. And I do like that it helped me, that like I mentioned to you earlier, Mike, that first 1x3 slice there,
Yeah.
that's what threw me. But you actually took that and used that to your advantage and saying, well, if it is cutting this 1x3.5, I know it has to have an area of 1.5 square units there because it is cutting it in half. We can even prove that with two congruent pieces there, right? It doesn't
Yeah.
it's a half that ends up with two congruent pieces. So that's lovely. Thank you for sharing that, bud.
No problem.
So if you want to keep playing with that, you are more than welcome to. But I'm gonna kick it back to Mike, who's gonna get us some new math to play with now. But again, if you're still in Geoboard land for a minute or two, we won't be mad at you because it's a great tool to engage with. But Mike, we're gonna kick it back to you to take us on our next task.
Cool. All right. Thank you. I appreciate it. Yeah. And we were thinking, Zach and I, we were playing in the session. We're like, okay, do we do like one task and like go deep with it and spend like 30 minutes and really building out the knowledge? And we thought we can do that. And we also realized that because we wanted to play in the spaces and use some of the less utilized virtual manipulatives, that it'd be really helpful, I think, if we do a bunch of different things with you. And the cool thing is that you have the share codes and we've left instructions and stuff for you. So any of these tasks we share with you, you can just play with. My colleague used to call these pillow problems. So if we don't finish something, you can just take it home and sleep on it, and then use it with your students. So now let's go a little into geometry. Let's go play into some stuff with the pattern blocks. So I'm going to start by just having us consider something that we can take for fact, which is we know the orange square, that all the angle measures of the orange square, if we were to think of like the interior angles of them, are all 90 degrees. I'm just going to make that assumption that we're all going to agree upon that. There's no need for math argument here. And so that's a fact that we can rely on. And I'd like us to now consider the other pattern blocks. And I didn't throw the tangent rhombus in here yet. It's just I was out of room and out of time. So it's just not there, but it still counts. We're going to explore that one as well. But I'd like you to think about what are all the other angle measures of all the other pattern blocks. But I don't want you using a protractor for this. What I do want you to do is we'll use the virtual manipulatives. And since we have the 90 degrees as sort of our benchmark in a way, can we start from knowing 90 degrees and then compare that square to some of the other pattern blocks and see if we can deduce what the other angles might be? And so the challenge is, can you find all the interior angles of all the different pattern blocks? And these are the instructions. It looks like a lot right now, but these are all written for you on the activity I'm going to give you the share code for in just a moment. But your first part of this is just to play around with like what I just described, like grab a pattern block and then you can layer other pattern blocks on top. And I'll show you just a couple of hacks that you can try with this as well. But you can try a few different things, and then when you determine it, you can use the text box and things to like write down what you think your conclusions are. And if you have time, and you may not have time for it tonight, just because we want to move on to some other things as well. But one really cool thing that comes out is problem number 3 is once you have all the angle measures, is to consider the sum of all those angle measures, the interior angles. So if you were to add up, like we know with the square, if we added up all the interior angles of the square, what would that sum be in the chat? And Zach, if you wanted to play with this while people are working on the initial part of the tasks, I know you've done the angle measures before. If you wanted to kind of play around with some of the interior ones just to start to notice some regularity, but not spoil anything, but just to give people something to think about a little bit. So everyone sees 360, right? So the wondering I'll have is like, what do you notice when we start exploring the other ones? What patterns do we see? And one other just extension, if you want, is we have right here, we have three-sided figures, we have four-sided figures, and we have a six-sided figure. Can you construct a five-sided figure as well and explore that? And could you maybe construct a seven-sided figure using the existing pattern blocks? So some things to kind of play around with. Now the share code for this is going and it'll get dropped in the chat for you as well, but it's 6SRJYBJ3. That'll take you to this. That's so funny. Every time I move my cursor on my other computer, it kicks that over. So it'll take you over to this to the actual task that I have here. But I want to show you just one other thing really quickly here. So just some of the features when you're playing with this particular task that I like. So I've grabbed the square right here. And if I want to explore, for example, the triangle, what I can do is grab that triangle. And one of the features when I click it is I can turn the fill off on it. So it could help me to kind of, and I could turn the fill off on the square too. So then I'm just sort of looking at it's easier sometimes to see the angles and things. So I could start to play around with this and I might like layer something else on and maybe see if this will fit on here. And you can work on the rotations and stuff. So you can kind of turn it in different ways. You can also take the fill off or keep it on, whatever you want, and then practice layering it on. And you can play around with this, see what kinds of things you notice. Can you figure out what the different angle measures might be? And anyway, just some things that you can do while you're playing with this. You've got all the things down here. And for the sum of the measures of the interior angles, I created a table for you that could just help you maybe notice some patterns as you're starting to fill that out. So take a few moments to play around with this. And actually, Zach, maybe if you wanted to play a little bit with, in just a moment, just kind of talk through some of your thinking around measuring some of the angles first. And then if you want to explore some of the interior angle patterns, we can go there.
That sounds great. And Mike, what I did was I actually and Jeff, if you get a chance to, yeah, God, they are on it over here at Braining Camp, man. I can't even get the question out before they start spotlighting. Mike, I didn't use your share code. I just came in here and did this. But what I'm going to talk through real quick, and I'm going to zoom in on this and go ahead and make this larger here for you guys. I don't know if you know this about Braining Camp, but one of the features they put in a couple years back was this option to zoom in or zoom out. I'm using my trackpad with like what you would do on your phone to zoom in or zoom out. It's a really lovely way to do it. You can also use the buttons over here if you like, but it's just as easy to use those motions we use on a phone to zoom in or zoom out. So Mike, I was thinking about first I wanted to think about the trapezoid for a second. And what's really tempting for me to do is to take, because it feels like this is going to happen, right? So what it's tempting to do is to take the tan rhombus and kind of slide that thing right here. And I
Mm-hmm.
feel like I got a right angle, right? Like that feels like I just created a right angle. And what I want to say is I want to be like, all right, well then they're 60 and 30. But can I prove that yet? I don't think so, right? Maybe it's 65, 25. I don't really know for sure what they are. So I have to do a little bit more. And one of the things that helps me with this is if I were to actually probably could have just duplicated that other tan rhombus. If I were to take this tan rhombus and put that one there, and then let's copy another one. I'm going to turn him just a little bit to do this situation. And so what I have now is another right angle, right? And so now I do know that if this is a right angle and all of those angles are the same, I mean, I use the same shape, I can just take 90 degrees and divide it by 3 to prove that each of these angles here is 30 degrees, right? 30, 60,
Yeah,
90, because they're all the same. Feeling good about that?
I like it.
And so then that means that if I take the trapezoid there and I look at that angle on the bottom and I were to put it with a 30-degree angle, it's 30 plus some number has to also equal 90. And I know that number has to be 60, right?
Yeah.
So now I just figured out two really big ones I think that can help me, right? I can use the triangle I know is going to fit in here, and I'll use your tip and take that fill off there. I know the triangle matches up with these angles of the trapezoid. So now I got another 60-degree angle here. So I'm at a
Yeah,
60 and a 30 and a 60. And that feels like a pretty good start to kind of use
love
some of
it.
the other ones to get moving around.
And what's cool with that, Zach, too, is like each time you discover one, it's like you unlock another tool. It's reminds me of
Yeah.
like video games, right? Where you sort of as you get more XP, you get like unlock new moves and things like that. And so now you've got not just 90, now you've got a 60, you've got a 30, and those are going to serve you really well, especially when you have to start to think about like the hexagon, but also I'm curious about you got the 30 on the tan thin rhombus. What about the other angle, the obtuse
I
angle?
figured you might be going there. You know what? The first time I did this task, Mike, what I did is I took a bunch of these here, the other angles, and I tried to layer them over this. This is going to get a little tricky with this, but I tried to piece all these in here so that they would match up. The other thing, but again, we can't use formulas because it is interesting right here to be like, okay, well, if this one's 30 on this side, I know the other one's 30, and then I know the other two are going to be equal to each other. So I have like a 2n plus 60 equals whatever the sum of the angles in a quadrilateral is, but I don't know that yet. So I'm stuck having to not be able to use that formula. And so what I'm going to try to do here without embarrassing myself too much is to try to layer these tan rhombuses up like this on its other angle here. And let's see how slick I can be if I can copy this. I'm going to try and impress. I'm going to try and impress Mark and Jeff here with my braining camp.
And while you're
So
doing that,
shutting it
Zach, I'm
all
going
up.
to make just as you're working, one thing that's really helpful with this task here, like, so we love physical manipulatives. It's always helpful. But what Zach's trying to do right here is virtually impossible to do with physical manipulatives because
Yep.
they're thick. And so as you're trying to layer things on, it's like it starts to like they just become unwieldy and they don't cooperate as much. And so the nice thing with the virtual manipulatives in this case is like you have a lot of really helpful everything kind of snaps in place and behaves the way it's supposed to. The other thing that's really important to point out here with virtual manipulatives, particularly with like blocks like pattern blocks, is even with the like so there's a lot of things that we can replicate with the physical manipulatives with the virtual manipulatives, but there's something different that also happens with the virtual manipulatives. So when kids are playing with these blocks, they intuitively will manipulate them. They'll turn them and twist it basically just do lots of transformations without thinking about it. But with the virtual ones, like Zach has to actually think about it. He clicks on it. He has to think how much he wants to rotate it. He has to think if he wants to flip it. Does he want to flip it horizontally, vertically? Like there are certain things around the orientation and the that kind of level of control that takes a different level of thinking with the virtual tools. So even if you have access to physical pattern blocks, giving kids opportunities to play with virtual manipulatives is a way to access that kind of thinking that they don't necessarily do with the physical tools. They don't need to do it with the physical tools because they just move it to fit the way they want it to fit without necessarily thinking about how many times they rotated it.
Yeah, and Mike, the other part that's so helpful with the virtual manipulative piece is that when a student creates this, I don't have to like try to carefully pick up their creation and take it up to the document camera, right?
Yeah.
For those of you if you don't know this, but if your kids are working in Braining Camp, they can just send you a share code. I'll do this quickly, but just remember this button's up here on the top right, so they can click share, and they can click this button here. And then they can send you their share code. They can send you a link or this just by copying this. And then you can project their work up on the screen right away. So if you're using a smartboard or some kind of other projection mechanism, that's a great way for them to share their work with you. They, of course, also, if you didn't see, that you can download an image or just copy an image. So both of those, if they downloaded it, goes to their downloads. Typically, it's a little trickier for them to find and email to you or whatever. But the share code is a really great way for you to take their work and get it up on the screen. And Mike, if you didn't notice, I was unsuccessful with those tan rhombuses there. Did not
I
tend
did
to match
notice.
up the way
I was going to say the exact, but thanks for owning it.
it did not work the way I wanted it to. So I got to do some more thinking on this one.
And
I feel
I'll
like
also say, Zach, for this task, like it is okay to use your power deduction. So you're 30-30, and then knowing what you know about quadrilaterals, like you can
yeah,
you can use deduction to do that. And just saying that for everyone, don't feel like You have to prove it all physically, but it's a fun stretch. Like when we talk about that specialized content knowledge, a thing that we can do as teachers to deepen our knowledge is to push ourselves. So like if Zach and I kind of like what Zach, he kind of you didn't even know you were modeling that there, but like he knew the quad like the idea that the quadrilateral is going to be 360 and he could do 30 and 30 and then figure out the other piece, but he kind of pushed himself to see if he can do it in a different way. And that's actually a good way for all of us to kind of think as teachers. In order for us to build that specialized content knowledge, we have to think about it more than just the one way we would normally approach it. And so we can try that way, and then we can try a different way, and maybe see it another way. And when we do that, it's when we get that deeper knowledge. Because when you're teaching in the classroom, you're going to have some kids who approach it the way Zach did, and someone else is going to approach it the way I did, or the way Mark did. And it gives us a more familiarity with these different strategies. And then because we think about how all these ways connect, we then can ask the right questions as we're facilitating this work with kids. So it's sort of all cascades and has a big effect. So Zach, I'm going to send it back to you to take us home with a primary task.
Yeah, so we thought a lot about this, and we did, some upper elementary stuff, maybe even some early middle school stuff with the last activity Mike just got us into. And we thought, you know what, primary teachers are almost always overlooked, right? Mike and I both taught in the primary grades, and we would go to so many math professional development sessions, and they wouldn't mention pre-K two at all. So we're gonna make sure we get you some pre-K or some primary stuff here, and that is gonna be with you using the two color counters. Mike has heard me um, ramble on about how much I love two color counters. I think they are hands down the most underutilized math manipulative. And the good news about it is, I'm willing to bet you have as many of these in your classroom as I do, which is they're everywhere. We always joke they were like gremlins, that they would just multiply at night or when they got wet. I forget which one. Mike, which one is it? You're my pop culture guy. Do
Yeah.
gremlins multiply when they get wet?
Yes, they do.
Okay, that's what it is. Okay, so the two color counters are like gremlins when they get wet. I got my joke right now.
Yeah.
And so they're just there's I have lots of them in the classroom, and so I think there are lots of ways that we can do that. So if you want to go ahead and open up the two color counters app, I don't have a share code for this one. You're just going to use the app in the beginning. In the middle, we'll have a share code that I would like you to use, but for now, we're just going to have you in the two color counter app. And so let me get you here. So what we're going to do is we are going to have a little activity called quick images. If you've never done quick images before, I'm going to give you a quick briefing on how this goes. What's going to happen is in just a second on the screen, you're going to see a representation of the two color counters. And in those two color counters, they're going to be arranged in some way. And all that's going to happen is during the time when I have it up on the screen, your job is to not do anything. You're trying to take a mental picture of what you see on the screen. And it'll be up there for about 3 seconds and 3 seconds only. And then what'll happen is I'm going to take it away and it'll look like this again. There'll be just a blank slide. And when the blank slide comes up, that's your cue to go over to Braining Camp and you're going to try and rebuild what I created from memory. Okay. Now, typically when we do quick images, you get 3 rounds of this because we want you to have some time to get it right, right? So I show you the image, it goes blank, you do some work. I show you the image again for 3 seconds, it goes blank. And then the third time I put the image up and then you can just make it look like mine. But the idea here, for those of you that aren't aware of some of the important work that we do in the primary grades, the idea here is that we're able to lean on this idea called subitizing. We're able to lean into the fact that our brains can recognize and perceive small quantities, but this won't be quite small enough just to perceive. You're going to have to do some what's called conceptual subitizing and put some pieces together. So what I want you to do right now is take your hands off your computer, just looking at my screen here. I'm going to go full screen. I'm going to show you the first quick image, and it's going to be only up for 3 seconds, and it's going to go away. Again, your job, try to take a picture of what you see on the screen. Okay, that was 3 seconds, folks. What I want you to do now, hop on over to the Braining Camp app, use those two color counters, and try to make a representation of what you just saw. And Mike, maybe what you can do in a second is just talk through what you saw. You don't have to try and recreate it in the app, but if you kind of talk through it while folks are doing that, that'd be awesome.
Perfect.
And we'll actually wait till the second time through. How about that? We'll give people a
Sounds
second to
great.
make it. I'll show it
Especially
one
because
more
I wasn't
time.
looking the first time.
Whew. Man, I don't know if you saw, but I figured out the tan rhombus. I got that top angle figured out.
All right.
I was still playing while you were talking.
I like it. That's when you know you have a good task, when you can't get away from it.
That's right. All right, let's see it again, everybody. If you're still building and you don't want to see it yet, that's fine. But if you're in a spot where you're trying to remember, was there two over here or one over there? We'll see it one more time. And then, Mike, I'm going to ask you to kind of talk about what you see, but you're only going to see it for 3 seconds. So here we go. Let's
All
make
right.
it full screen. And we go 1, 2, 3. Mike, you want to talk through that? Tell us what you saw.
Sure. The first thing, my eyes were drawn right to the red. So those four clustered together like a little square. So I saw that. And then it looked like little ears. So it's like a little square head. Then I saw like the two, there's one yellow on one side, one on the other. So like two little ears. And then like I kind of lost the shape, the head shape from there, but I just saw there was two on the top. I was going to force it to be like a hat or something, but then I lost it when I got down to the bottom part. It was like, all right, was that like a, what do you, scarf or something like that. So it's basically four red in the middle, two on top, two yellow on top, two yellow below. So that's eight, and then 9, 10 on the for the ear part there.
All right, let's put it back here and see what we got. So Mike talked about those three in the middle. We have to lean on our colleague Tony Cameron and her book, where she talks about routines in the primary classroom. Typically, you might build this where they're all yellow, but in this case, I changed those middle ones to red so that it would draw your eye to that, right? Otherwise, it's kind of hard to kind of picture like what it all is. And so now you're seeing a 4, a 2, a 2. That's how Mike saw the top two and the bottom two, and then the other two on the side over there. So we have a total of 10, right? And now for the primary teachers in the room, you know what we're doing, right? I'm recording on the board. 4 plus 2 is 10, right? Or 10 equals 4 plus 2 plus 2, right? I'm generating equations that in the way that Mike is talking about this, right? Like Anna said, or Anna said, I saw 4 2 2 2 as well, right? So another way we might see that. I'm going to show you a couple more of these quick images, but in the spirit of time, because we've got a couple other things we want to share with you, in the spirit of time, we won't actually play them with you, but this is another fun one to use. So in the Braining Camp app, you can use the tools section and drop a 10 frame in there. I love using 10 frames like this for quick images because when I do something like this, I now inevitably someone will say, I just moved one of the red ones over and I saw a 10 and a 6. And what they're saying is the sort of like make a 10 or pretend a 10 strategy, right? I'm sort of like taking one from this number and moving it over there to make it a 10. And now I can see 10 and 6. This is the math of like the associative property and all of that, right? So like lovely math that can happen from this. And then I did create one more for you that we won't do, but this is sort of like maybe a second or third grade one as you're starting to think about multiplication. I love this one a lot. The other thing you should know about the two color counters app in Braining Camp is you have the option to just drop one on, or you can drop groups of 5 or groups of 10. And so I create this one really quickly by using that group of 5 option to drag them over. So that was a really lovely way. This one's a little sneaky if you haven't seen yet because they are not exactly the same shape and size. You have a 3 by 5 and then a 3 by 6. So kind of throws you off there in a quick version there. And so, yeah, so those are three quick images that you may want to use. I'm just going to pause here and just let you guys know about a community that Mike and I have that we'd love for you to come be a part of if you're enjoying this kind of thing here. So we have a community called Friends of Flynn Education that's free for anyone to come join. You can just use that link at the bottom or you can scan that QR code. We do 4 things every month. One, we have a math play date that someone from our team or someone from that we know in the world comes to join us. We had Howie Hua last week host our November play date where we bring a math problem and we play as learners. A lot like what we did tonight, but in sort of what we might call non-routine math problems. We also do a live interview with a friend or colleague of ours in the math ed community. This month, we're interviewing Lisa McConchy. She has a new book out on the brain and how our brain impacts our math identity. So that's super fun. And then we release free, ready-to-use tasks every month. Mike and I record short, little 5 to 10 minute teacher and leader videos for you to use that you might be able to use in a PLC, or you might just learn a little something. So if that sounds interesting to you, we'd love to have you over there. Again, free to join us. We don't ask for anything other than just when you can join us live to come join us live. It's a super fun time. And then I think Mike's going to tell you about one more thing, and then we are going to turn it back over to our friends at Braining Camp.
Cool. And yeah, the last thing I just want to share with you all is so on top of this, the community that we have. So all the math activities we've done with you tonight are all actually from our online courses. So you may notice that Zach and I are in looks almost like TV studio kind of things. So we, as much as we love to travel the world, and we're in schools all around the world. I'm going to be going to Beijing again in January to work with teachers and things. We also really realize that access is challenging. Not everyone can fly people in and do professional learning. And we realize we have a lot of really good stuff to offer to build teachers' math content knowledge. That's what our commitment is. And so we've taken the time to build out a studio to record really high quality professional learning courses, full graduate courses for math teachers. Right now, we have a whole suite of them for every major domain in mathematics to build math knowledge for teaching from grades K through 8. And we are presently building high school courses to basically fill the rest of the range here. And so if you go to our website, flinteducation.com, you'll see a wide range of them. But I'm just showing you here, like when we talk about like the highly engaging, highly interactive. So we're doing a lot of the math, but then we also we as instructors, like we utilize all the technology so we can kind of show all the different ways that we can think about the math and visualize the math. So it's really powerful. We have a lot of cameo appearances by good friends and things in our courses. And again, we're able to make this really dynamic and interactive. And what's really great with the courses, the way we run them, is that a lot of times what happens with online courses is that it feels like you're disconnected from people. And we didn't want that. So one thing we worked really hard to do is to make sure that we film teachers doing the work. And so, for example, we have in one of the courses, you'll play a math game close to 1,000. You'll be trying different strategies on your own. But then as you play, each time you take a hand, you watch these teachers for like a 2-minute clip of them strategizing using the exact same cards you have. And it pushes your thinking. We'd have teachers actually say, like, I thought I was done, but then I watched their strategy and it made me rethink all my moves. And so we wanted to make online learning not feel like online learning. Zach and I really worked hard with our team to create this really dynamic experience. And if you're interested in that, check out our website and see if this is something that you may want to learn more about and to bring it to your school and to your teachers. So we'd love to continue to work with you. So thank you all for joining us tonight.
Thanks, everybody. I think Jeff and Mark may have a few closing words for you guys.
Awesome. Well, I sure learned a lot, and I always enjoy learning from you guys. It was a pleasure to meet you both in Atlanta a few weeks ago for NCTM. Thank you so much, all of the 120 of you that joined this webinar tonight. Hopefully, it got you excited about teaching math. Thank you so much.
Yeah, I'm just going to reiterate some of that. Thanks to all the participants. Thanks for being there in the classroom for kids and what you do. We know how tough it is, how difficult of a job it is. So thank you, Mike and Zach. Thank you as well for what you do to make a positive impact in math education. So we are very appreciative to have had you here tonight. And you can see on the screen I took some liberties. I put your website address up there.
Thank you.
And then I also grabbed your email from your website if you want to get in contact with them. I'm thinking most folks that after tonight, they're probably like, yeah, I'm going to get in contact with these two. I want my school and/or district. And then lastly, there's a support email at Brainy Camp if you're having any additional needs or any additional tech issues. We're more than happy to help. So Mike and Zach, again, thank you. Appreciate everything you do. And yeah, thank you. It was fun.
Thank you so much.
We had fun
All right.
too.